Everyone, welcome to the afternoon. Hope you're still well caffeinated. Yeah, so you might have seen on the schedule, Pete. I am not Pete. Fun fact, my name is Mickey. But we love Pete anyway, and we collaborate together on a lot of stuff. Yeah, okay, so short title. You guys have probably seen a lot of the product features and releases today, and so what we kind of wanted to do was actually pull it together and show you, like, okay, like in a prototypical agentic application, how would, for example, Voyage come into play? How would Atlas come into play? Where does agent memory start feeding into creating stateful apps? Bam. Sorry, my bad. Yeah, that's a lot of bullet points. Worked many years for both early, late-stage startups. Everything from doing data ops to ML ops, and now working with AI engineers. Yeah, so in terms of how I like to run things for demos, I'm going to give you kind of just enough pieces. My goal in terms of, as a staff developer advocate, is I create tutorials, I create open source projects for you guys to fork and honestly make better. Because while I'd like to think I'm amazing, I'm not. You guys are probably way smarter than me and way more capable. So please do check out the demo when I hand it over to you. Okay, so we've all seen this MIT paper, right, called the, it's from the Nanda group, and they had this number, right, that was okay, 95% of these pilots are terrible, they're not doing anything good, but there are 5% that seem to do really well, they seem to bring a lot of value, and they seem to be very useful. So there is a key point, and they call this the Gen AI divide, right? And so a key insight that they had brought up was this, which is that why is it that a $20 consumer app, well, at the time it was $20, now it's more, but why is it that a $20 consumer app was able to beat out, let's say, a $20,000 to $50,000 enterprise deployment? And a huge part of it had to do with statefulness, personalization, learning, and memory. So what we're going to do is we're going to talk through kind of how you can use Voyage, Atlas, and so on and so forth to provide these things, and also what are the trade-offs in terms of when do you use an agent versus not, when do you bring in memory versus not. Yeah, what I said. So in terms of kind of the trajectory, now many of you probably know a lot of this, but we do hear things from people where they say, well, we have big LLMs and we have agents and therefore RAG is dead, boo. Oh, and we don't really need to care about search and search patterns and optimization because agents, boo. And that's really not, it's not the case that these are mutually exclusive tools or patterns, right? They do build on each other, and most importantly, within the same app, you can essentially leverage all of these. So with search, for example, it's about finding relevant content. Now, regardless of whether that search is semantic or full text, right? You could use it naively. You could have RAG, where you take that same content and then you clean it up nicely and present it. And then you have Agentic AI or Agentic RAG, where essentially RAG is a tool. Does that mean you can't have a RAG tool and a search tool? No, you can have all of them. So we'll see all these patterns, but it's something important to remember is that it's not just one or the other. It's really kind of figuring out what are the weaknesses and benefits of each one, and when do you bring them in? Okay, so this demo / project, I'm going to be real. You've seen much more impressive ones at the Cerebral Valley hackathon. And that's because I made life harder on myself. The constraints I gave myself for building the demo was one, no frameworks. So this is just pure Python, MongoDB Atlas, Voyage, and I use a bunch of Anthropic models. But that's basically all it is. The second constraint I kind of gave to myself is to try to implement a good number of memory patterns purely within Atlas. and then see how I could start building in dynamic tool discovery. So right now, I'm going to show you the V1. The V2 and V3, I encourage you guys to actually like fork this and go build it. I'm personally inspired by projects like Whisperflow, et cetera, because the thing I hate the most is like giving updates on what I did that day. It is painful. Updates on what I did, updates at the end of the month, updates at the end of the quarter. And also the way I kind of track my own work is actually very disparate. So my favorite thing to do is, yes, I take notes in Notion. I also do audio memos on like my iPhone, all sorts of stuff. But I really kind of want something to work with me. So this is a V1. Yeah, but what I would say is that regardless of whether you're, for example, an early stage startup building your own sort of productivity agent, or you're a more enterprise company that's building something internally, a lot of the problems I ran into and challenges are going to be ones that we all face regardless of the domain and industry. Now, let me talk through how I've just structured it so far, and kind of the reasoning, and maybe some of this will resonate. So first off, it's a multi-agent architecture. And what do I mean by that? We have a coordinator agent that essentially does a lot of routing, right? And we have kind of 3 pseudo agents. And when I say pseudo agents, I mean like 2 of these are kind of more like thin wrapper libraries for methods. And one of them is a little bit more of a real agent, right? Now, what'll happen is essentially, I'll show you a bunch of different queries, but the coordinator agent will do a couple things. It'll identify, first off, is this something that needs to be handed off or delegated to another agent? Or is this something that could be called its own method? But even before that, I do have some amount of processing pipelines. Now this third one, I call it the MCP agent. I utilize a single MCP server here, Tably for web search. But this is going to be one that's open question, homework, take-home assignments, right? Because I'm going to propose a potential idea, and you guys can tell me whether or not it's silly. Now, the different interaction methods. So who here is currently doing kind of context engineering in their agentic applications? Very cool. So I started thinking about, well, obviously implementing context engineering methods, but also this question of what do you dump in an agent, when and where, right? And that is a non-trivial problem. And then, of course, I started reading a lot of people saying that, well, we can go back to the olden days. Well, okay, so Kelsey Hightower made this joke a while back where he's like, why don't we just run essentially pipelines of bash scripts? Why don't we do that before we even deal with agents? And I thought that was kind of a cool idea. So there's 2 kind of, well, 3. Okay, there's kind of 3 or 4 interaction methods. So the first one is direct slash commands. These they run direct MongoDB queries, right? They're going to be the fastest. Even within there is still a little bit of a range. But this is for example, the people, your users like me, who, if there's something just very specific we want to retrieve really fast, right? There's a relationship between how much time the LLM should take and what the expected payoff is. And for very simple queries, I want it to be immediate. There are also queries that are written in natural language, but you could arguably essentially still map them to a direct slash command, right? So that's kind of one bucket. And those will take milliseconds, sort of, kind of, yeah. Any numbers that you see, by the way, please don't think that that's the actual numbers for how fast Atlas runs or any of these pipelines. Know that I'm a very mid engineer, really mid. So these could be very much so optimized in better ways. But the second class of like queries that I can put in are more kind of complex. They won't map really cleanly to slash commands, or if they do, it's like you have to stack those slash commands, or even like they require a little bit more research. So that's roughly the two big categories. But even within that, there's kind of like subcategories of interaction methods. Okay. Cool. Okay, so let me just walk you. This should be pretty explanatory, but this is Flow Companion. We have some sample data here. Looks about right. If you recognize the anime that these names are pulled from, feel free to shout out at some point. Anyway, so pretty typical chat with your to-do list app, right? Now let's talk about another showcase. Like, so, for example, we have this slash tasks. Right, and this is literally just like it's a filter. It's not even a filter, it's a list all, honestly, on the task table. Sorry, let me roll back. Let me quickly show you the actual collections that we have. So there is 7 collections. 3 are essentially memory types, which I will explain. The 2 are the projects and tasks, and then we also have tool discoveries, which I'll talk about later. We can just plop right in there. You can see some examples. If you so love tables, there's a way to view it as a table. And then this is tasks. So a lot of pretty simple stuff. My God, that's terrible to read. Apologies. So slash commands, right? These are pretty fast. We can add some filters, all that good stuff. Now, in terms of the optimizations that I've applied on the context engineering side, so for this, I am using Sonnet 4. I've done a number of things: compress the results, streamline the prompt caching, all that good stuff. And like, yeah, so let me just kind of plop through here. Go to filters. Now, kind of the first learning goes back to what's kind of the easiest way to ensure speed and efficiency. Don't route something through an LM, right? Figure out what are some easy commands or what are some like easy user experience wins that you can implement, and essentially kind of get as close to like a direct query as possible, right? Now let's go to, really quickly, let me show you the natural language commands, or the slash commands that really kind of masquerade as like natural language commands. Right, so what's in progress? Yeah. Right. Now with these, for example, I'm using direct like text search, direct text search, but also just running it against the index. If you can kind of get it down to essentially like a slash command or a query, you're already going to be in a really good spot, right? So that's one trade-off to initially think about, aside from all the context engineering optimizations. Oh, sorry. Yeah, okay, demo. Right, sorry, slides, thank you. Okay, so I did mention that I would kind of start introducing you to the concept of memory, right? So we do have some like blog post materials on this, but just kind of a starter terminology. So most of this terminology came out when we had this idea that we wanted to model agents off of humans because we just assumed that humans were like the best, most efficient creatures in the world, right? So that's where some of this terminology comes from. There are various like memory frameworks, some of which we are integrated with, like Mem0 and Agno, where they have their definitions and implementations, and you should definitely consider using those frameworks. But a lot of them just come down to this kind of stuff. So working memory is whatever we keep in like the LLM's like context window, right? We have shared memory, and this is important between multi-agent handoffs. And then we have essentially three types of long-term memory. So episodic, which is like things that can be organized in terms of like events or by time, right? Stuff that happened. We have semantic memory, which is like conceptual knowledge that you could essentially search and retrieve based off of vibes and similarity. And then we also have procedural memory. So for example, maybe there's a complex multi-step workflow. Instead of having the LLM kind of like reimagine that plan every single time, what you could do is you could actually just save that off, and then essentially when like the agent, like you say, okay, blah, 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 agent goes like, oh, I know we've kind of stored this procedure someplace, so why don't we go ahead and like download it, right? And then load it then. So that's another way you could actually kind of save some efficiencies. Yeah, and I'll go ahead and show 3 of those here. Okay, excellent. Okay, so what does that memory look like? So first, let me just quickly kind of peep in and give you an example. So here, for example, this is episodic memory. And where that looks like in the app is if we go to each project. For example, I've like pre-generated, so I've initially pre-generated these summaries that then get stored with the projects and tasks. But I also have logic where every time I do essentially some more activity updates, it could then kind of regenerate that, like generate a new summary on the fly, right? So that's one way episodic memory can take form. The next memory that we have is procedural, and I'll show kind of what that looks like. But in this case, for example, going back to it can be a little bit complicated to like chain a bunch of tasks together or chain a bunch of steps and then expect the LLM to kind of regenerate it each time, especially if you're, for example, experimenting with different LLMs. And so what I've done here is I have a couple of these like workflows and streams, and what it'll do is it'll go ahead, it'll identify it, and it'll load it. And I do that through a form of search called Semantic, or sorry, hybrid search. Hybrid search, which is a combination of full text search and semantic search. And finally, there is semantic memory. I've already kind of pre-populated with some stubs here. But we'll go ahead and see how that runs. OK, so first thing I'm going to do is plop over. So let me just show you what we have here really quick. So what do those templates look like? OK. So I have 3 templates. The first one is a GTM roadmap template. It's a go-to-market plan, and the idea is that, let's say, for example, I need to come up with a new product feature, right? So let me go ahead and plop over EAs. I was really bad. I did some, last-minute bug bashing with CC, aka Claude Code, about an hour before this, which, is not always the best thing in the world. OK, so what happened here? So let's say, for example, I want to come up with like an OS for an open source OS for managing autonomous fleets. So the first thing I did was I said, hey, what do we have? So what do we have in terms of what do we know about it, right? And it did a couple things. So this is a hybrid search pipeline. It combined full text search, so it'll go and find the keywords and things like that. But it also found entries in this semantic memory collection to then kind of show and also give me the confidence score. So there's a couple of different stubs that we have here. And then, yeah. So it found some stubs here, but it didn't find necessarily like existing projects or tasks, which is honestly good, because we want it to be a new thing. Yeah, let me just quickly. So actually, could we pop over to slides really quick? Awesome. So these are the various modes that are available, for example, in the app. So full text is I'm trying to find a specific project. Semantic is literally like, go find me the thing that's similar. But let's say, for example, your user wants to get some results, regardless of like how amazing they are. That's what you can use hybrid search. And in terms of speed, you can literally follow through this way. Full text is going to be fastest. Vector search is going to be a bit slower, and hybrid search will be quite a bit slower, but it can give you the essentially best combination of exact results and good enough results. Go here. OK. Now, fun kind of homework. So I did mention that there would be some like open questions, right? Let me go ahead. OK. So one idea that I've been playing around with, because people are talking about long-running agents, right, is right now, as I went through the app, I was essentially going like to Claude Code, analyze the logs. OK, tell me where it's screwed up. Tell me where we need to query. So a fun thing that I'm going to try, but I also encourage you guys to try, is see, for example, could you set up a self-refinement agent that improves essentially the experience? And what do I mean by that? What I mean is doing something very similar to what we did. So you could take like a virtual sandbox, like E2B. I've worked with them in the past. They're pretty cool. Could you then set up like a VS Code instance, install, for example, the MongoDB MCP server, and essentially create an agent loop where it'll run those queries against the app, and then it'll store that in essentially a long-term persistence to analyze, such that you can then generate better, more efficient queries, or even generate the queries that your users don't have. So those are some things to think about. It could look something like this. OK, and the last one is, I might have skipped a few steps. OK, so I mentioned I was going to do some research. And I said, OK, I want to essentially create like a GTM plan for a new product feature. Please go do that. So it's going to run. Hopefully it won't error. But if it works out, what it'll do is it'll go first to the procedural memory. It'll pull the template for creating a GTM roadmap. Then what it'll do is it'll take that research, it'll inject it, it'll provide little summaries for each task. And then ideally what I can do is I can say, OK, well, can you find me similar projects or similar tasks to what I just created? And it's kind of similar to how we all work, right, in like our company setting, is we're given a project, we're given a feature. There's already been some work that's been done. Maybe we want to connect the dots there. I swear it was faster like 30 minutes ago. It is generating at least like 12 LLM calls. So, OK, there we go. Boom. Blah. OK, blah. So this is the episodic memory. And if we go here, this is essentially the research that was then consolidated, and then it was matched and added in. And user. OK. So last but not least, if we could go here. So I made life really hard for myself. I did this on hard mode. The reality is you don't have to do it on hard mode. And there are a number of ways you can make life easier on yourself. So the first one is we have a number of integrations with agentic orchestration frameworks, as well as memory frameworks and libraries. So I would highly recommend checking them out. But if you ever feel like you need something more custom, you absolutely can build it in Atlas very flexibly. And you can also link your memories to the actual operational data. And even most importantly, with the introduction of a feature like auto-embedding, you can have as you upload documents, you can have that embedded automatically have that ingested, and then you don't have to do the spaghetti code and pipeline. Finally, going back to that homework of, could you essentially do a self-refinement agent that, for example, tries a bunch of queries and writes them out? We do have some of those features. For example, we currently offer a text-to-query capability through LangChain. Please do check that out. And we also offer short-term memory and long-term memory checkpoints as well. Cool. Thanks, everyone. I'm on LinkedIn. Just send me an invite. Say, hey, I had questions. I hated your session, blah, blah, blah. It's cool. I accept it all. So please do connect with me on LinkedIn. Here's some things you want to check out. In our GenAI showcase, we have tons of examples where, once again, we use a lot of the major frameworks. Please feel free to fork that. Create an issue. Say what you loved or hated about it, and then go ahead and improve it. Because with essentially all the collective brainpower here, I know you guys can come up with something way better and way cooler. So thank you, everyone. Hope you have a great rest of your day.